Hello everyone, good morning, good evening to all of you. So in this today lecture, I am going to teach you about something ordinary differential equation. So today class, I am going to teach you some more maybe I hope you know better to understand this. Okay. Yeah. So today I am going to teach you. Okay. That is linear differential equation. And it is a part of ODE. In last class, we study about something, maybe something basic concepts related to this. So today I'm going to teach you one more concept that is linear and nonlinear differential equation. So what is linear differential equation? First question is that. So maybe a linear differential equation you have like order n. Okay, if order n in the dependent variable y and independent variable x. So is an equation can be expressed as like this: a0 x dy. Wait a minute. A0 x dny upon dx to the power n plus a1 x d to the power n minus 1 yx upon dx to the power n minus 1, and goes to, you have some an minus 1 dy by dx plus anx yx, which is equal to phi x. Okay, that is the and a0x, which is not equal to 0. So this is basic things. You know it very well. In last class, I am going to teach you some this kind of things. Okay. So today it is a part of linear differential equation, ordinary differential equation, and topic is linear differential equation. So these are the kind of representation of linear differential equation. If you have order n and a dependent variable y and some independent variable x, then you represent like this. So you may say that it is a type of linear differential equation. Now next thing is that very important. First one is you may be degree degree of y and its derivative is 1. Okay. And second thing is important, then is no product of y and its derivative. Okay. Now that is, you may say that here is some example based on it. You may take first one example like this: d2y upon dx square plus 6x dy upon dx, okay, plus 10x square, which is equal to 0. Okay, these are the kind of linear differential equation. Now, here the second example like this. If you have some 10 d2y upon like this dqy upon dx to the power q plus 6x square d2y upon dx square plus y which is equal to 0. This is the kind of linear differential equation. Okay. So first be aware about what is linear differential equation. It is nothing but when you have order n, you go for the order n and dependent variable y and one of the independent variable x, then these are the representation of this linear differential equation. Now for I am going for nonlinear differential equation. So what is nonlinear ordinary differential equation? So nonlinear ODE, it is nothing but example like this. First example is d2y upon dx square plus 6y dy upon dx plus 10y square which is equal to 0. These are the kind of nonlinear differential equation. And one more example, take 10 dqy upon dx cube plus 6y square d2y upon dx square plus y which is equal to 0. This is another kind of non-linear differential equation. These are the example. Now move on solution of simple ODE. Okay. So what is solution for solution of simple ODE? I'm going to teach you solution of simple ODE. So let's one more concept here. Let function like this f x y dash up to y to the power n which is equal to 0. Okay, and yx, these are my first equation, be a simple ODE. Okay, then phi x is called solution of simple ODE. Okay, if in case first, if phi x has nth derivative and second thing is phi x satisfy, then differential equation like this, that is function of x phi dash up to phi to the power n which is equal to 0. Okay, so I have one more problem which is based on this type of possible solution, so I'm go for the problem. Okay, these are the kind of solution of simple ODE, nothing but it is a representation like this, fx y dash goes up to yn which is equal to 0 and y is equal to yx. These are my first equation, be a simple ODE. Then phi x is called solution of simple ODE. Okay. So in first case, phi x has another derivative. Okay. First kind is that phi x has another derivative. And second thing is must be satisfy this differential equation. So we say that this is a solution of simple ODE. Okay. Now I have one question based on it. So question is, which of the following is our possible solution of a0x plus y double derivative of x plus a1x y dash of x plus a2x yx, which is equal to 0. Okay. So these are the kind of second thing is x belongs to R. And here is the option here. First option is yx, which is equal to x square. Second is yx is equal to modulus of x. And for third, yx have some function like this, 1 minus, it means modulus type, where x greater than or equal to 0 and x is less than 0. And fourth option is not. So maybe these are the possible solution for this. Okay, this kind of representation. So it is very well about this, and these are the answer option. Okay, try this at home. So I am going to give you some more problem which is basically based on it and for SW part. Okay, so here is some question based on it. First is fx is equal to modulus of x. Okay, and second is fx is equal to modulus of x square, and next one is fx is equal to modulus of x cube. Okay, and last one is fx is equal to modulus of x to the power 1 n, where n is the number like this. Okay, so your question is which is differential or not. Okay, try it at home. These are the SW part. Now I'm going to move you one more problem and maybe solution I provide you. Okay, so here is one more question, and question is, let y is equal to x modulus x, mapping x belongs to R, be a solution of f x y y prime y double derivative goes up to y to the power n, which is equal to 0. Okay, then the possible value of n. Okay, and here is some option. Maybe option first is 1, second is 100, third is 2, and D option is what? Not. So first thing is in this question, how you solve this problem. Okay, so first you have some function are given already in this part, y is equal to x mod of x. Okay, so you know it very well how to implement this. So for yx you have some modulus already are given. So for yx you have, for modulus function you have to justify like this. When you put here the minus x and a plus x, then you have multiplication like this, and the value is x square, and second thing is minus x square. These are the x greater or equal to 0 and x which is less than 0. So whole thing is about this function maybe represent like this. Okay. So next thing is that to check whether to check the differential equation. Okay. Or not. It is differential equation or not. Second thing is find left hand derivative and right hand derivative. And lastly, if both equal, then this is differential equation. So how to solve this? I am going to solve. Okay. So first thing is that you have already function are given. Now here say that the left hand derivative and right hand derivative. When you go for a derivative, it is 2x. Okay. And second thing is minus 2x. So you have some function already given 5x. So maybe write like this 2x where x is greater than equal to 0. And second thing is minus 2x where x is less than 0. Okay. So now move on the for limit part. So here is limit when n tends to what? N tends to 0. Okay. So for n tends to 0, it is already the phi x will be phi x is equal to 0. Now y is what? A y is differential equation already. And second thing is here is phi x already are given. Now move on next derivative. So when you go for the next derivative, you got like this type of function are come. So x and minus x, where x is greater or equal to 0 and x is less than 0. So here you show that RHL which is not equal to LHL. Okay. It means for what? For GX. Okay. At x is equal to 0. Now next thing is that when you got this, then you maybe say that phi x is not differential equation. Okay. So your option are given here. Yeah, here is 1 and 2 and 3. Now, when you again differentiate this, you got answer like this. Your option is first or correct. Again, one more problem, basically based on modulus type of problem. Okay. Yeah. Yes. Second problem is this like this. So in second case, you maybe justify like this. How many solution of the differential equation? And the differential equation is dy upon dx plus modulus of y which is equal to 0. Okay. And x belongs to R. So your solution look like this. So your solution part is let yx which is equal to c, and first thing is go for 0 and second thing is not equal to 0. Okay. If if c which is not equal to 0, then you may say that yx which is equal to c. Okay. And therefore imply modulus of y which is less than 0. Okay. which is less than 0. Therefore imply dy upon dx which is equal to 0. Okay. So lastly, you have already equation are given. The already differential equation have dy upon dx plus mod of y which is greater than 0. Okay. So this case it is does not satisfy equation. Okay. So therefore imply yx equal to c is not a solution. Now go for second part. That is if yx is equal to 0. If if yx equal to 0, then you say that its modulus function which is equal to 0 and mod of dy upon dx which is equal to 0. Okay. So next thing is that modulus of dy upon dx plus mod of y which is equal to 0 and which is equal to the next thing is y is equal to 0 and differential. So therefore imply yx which is equal to 0 is a solution. Okay. And the next thing is therefore imply if yx which is not equal to c, that is y is equal to yx. Okay. And there exists x0 belongs to R such that yx0 which is not equal to 0 at x is equal to x0 and say that dy upon dx that are equal to 0 and second thing is yx0 which is greater than 0. Okay. So therefore imply dy upon dx plus modulus of y greater than 0 at x is equal to x0. Okay. Therefore imply y is equal to yx is not a solution. Okay. Now next thing is therefore imply yx is equal to 0 is only solution of this kind of differential equation. Okay. This kind of differential equation. And the second thing is if very important if yx equal to 0 is a solution of differential equation, then it is trivial solution. Okay. And second thing is if yx differential equation has non-zero non-zero, then say that it is non-trivial solution. Okay, these are two basic assumptions we got for solution. Okay, so in this question, maybe you understand better. Here is some differential equation are given already. And first thing is when you got this, first one is go for C is equal to 0 and second thing is for not equal to 0. So if C not equal to 0, then Yx is equal to C. Okay. And the first thing is here the modulus Y. So modulus Y is greater than 0 and dy by dx is equal to 0. So first thing is for dy by dx, for here is the modulus of y which is also greater than 0. So this does not satisfy the equation. Now go for the yx which is equal to c. That is the not a solution. Now move on. Next part, if yx is equal to 0, then modulus is equal to 0 and dy upon dx is also 0. So whole thing is equal to 0. So for y is equal to 0 and for differential equation, here is yx is equal to 0 is a solution already for yx is equal to 0. So if yx which is not equal to c, so that is y is equal to yx and there exists x0 which belongs to r such that yx0 which is not equal to 0 at x is equal to x0. Therefore, the modulus is dy upon dx which is greater or equal to 0 and yx0 is equal to is greater than 0. So whole thing is here is also say that y is equal to yx is not a solution. Now yx is equal to 0 is only a solution of this kind of differential equation. So lastly say that if yx is equal to 0 is a solution of differential equation, then say that it is a trivial solution. And next thing is if has non-zero value, then say that non-trivial solution. Now next question I have, uh, here is one more question based on this. So question is consider the differential equation, and differential equation is d2y upon dx square plus modulus of y equal to 0 minus 1 minus 1 equal to 0 for all x belongs to R. Okay. Then which of the following is correct? Okay. So your option is differential equation has not solution. B option is differential equation has only trivial solution. C option is differential equation has at least one non-trivial solution. So, and D option is not. So hopefully you understand the trivial solution, non-trivial solution very well. In trivial solution, the value is equal to 0. Then you say that it is a differentially trivial solution. If you got some value which is uh, equal to 0, then say that it is a non-trivial solution. And if you got non-zero, then say that it is a non-differential equation, non-trivial solution. So here is some question are given. Now move on the solution part. Okay, take a screenshot. and first you try, then I move on the solution part. Okay, so here is solution. These are the gate question. Okay, so the in solution part there is the two thing. If y is equal to 0, say that modulus of y which is equal to 0, therefore imply d2y upon dx square which is also equal to 0, and you have some this kind of differential equation like this, na? d2y upon dx square plus y minus 1 which is equal to 0. Okay, already this kind of differential equation. Now, so when you have some this kind of, so put here 0 and 0, and lastly you get minus 1 which is also equal to 0. So you say you may be got like this minus 1 which is not equal to 0. Therefore, you may say that yx is equal to 0 is not a solution of differential equation. Okay, so these are the kind of y is equal to 0. And second thing is, if yx which is equal to plus 1, then d2y upon dx square which is equal to 0 and y is equal to 1 is constant. Okay, so these are the kind of y is equal to 1 is constant, and maybe 0 plus 1 minus 1 which is equal to 0. So 0 is equal to 0 and therefore imply yx is equal to 1. So it is a solution of differential equation. Okay, now move on next part. If yx is equal to minus 1, okay, if yx is equal to minus 1, then d2y upon dx square which is equal to 0. Therefore, you have already na 0 plus 1 minus 1 which is equal to 0. Okay, so here is already modulus part are given now. First I correct, then show you. Here is some already a modulus part are given. Yeah, minus 1 and hopefully minus 1 and modulus change into plus 1. So minus 1 equal to 0. Therefore imply yx which is equal to minus 1 is a solution of differential equation. Hopefully you understand this better. Now, if last thing is, if y which is not equal to plus minus 1, okay, and y is equal to c, then how to solve this? Okay, if this kind of, then y double derivative which is equal to 0. Okay, and therefore imply 0 plus mod of x minus 1 which is equal to 0. Therefore, modulus of x which is equal to 0 and x is equal to plus minus 1. So these are the kind of your assumption, and here you got some value. Then you say that it is a non-trivial solution. So here is some at least one non-trivial solution you got now. So say that these are your correct option. Okay, and all things are not. So these are the also kind of some differential equation. Now move on next part, which is our next topic, that is formation of differential equation. Okay, so I have some. Firstly, I am tell you some problem, then discuss the formation of differential equation. Wait a minute. Yeah. Now here is formation of differential equation. So I am going to discuss one problem. So here is question are, let f have some value fy 0. These are the kind of family of circle whose center on x-axis and radius is 5. Then find the differential equation corresponding to this family. And this is my last question. Okay. So you know the very well what is the family of circle and their center when it is from X type. So maybe look like this. Yeah, my figure is not good, but try to understand. Okay. These are the family of circle which have some center on x-axis. So these are the kind of some circle you have. Okay. These are the circle only. So first thing is, you know very well, if you have some family of circle, then you have equation like this, na x square plus y square which equal to a square. So here is a family are given here, f function are f x y 0. Then mm, family of circle, you write like x minus 6 square plus y square which is equal to 25. This is your first equation. Okay, because radius is 5 na, and you know it very well. y square is equal to a square is your radius. And you here teach, talk about some center at x-axis and radius is 5. So these are the family of circle and representation like this. So now move on for differential part. Now differentiate with respect to x. And what you got? You got 2x minus a plus 2y dy upon dx, which is equal to 0. Okay. So now second thing is, if you got like this x minus, hold on, x minus a, which is equal to minus y and y prime, why this kind of problem like this? Y prime plus y square, which is equal to 25. Okay. Now go for the next part. Y square dot y derivative like this, which is plus y square, which is equal to 25. And next thing is y square in bracket y prime square plus 1, which is equal to 25. So this is your answer. Okay. So these are the family of circle which have radius 5 and center is what? Center is your like this 1, 0, 2, comma 0. Okay. And second thing is 3, comma 0. Move on when you move on second steps, then you got this type of. So I have one more problem, but maybe time is over now. So maybe in next class, I hope I am teach you some type of solution, that is general solution, particular solution, and some envelope already, and then move on the first order and first degree in differential equation. So today class is only this. Now, thanks for watching these videos. Meet on next time on new lecture, new day. Okay. So thanks for watching these videos.